Welcome back. In this video, we're looking at the sequence n squared minus 7n plus 3 over negative 4n squared plus 10n plus 1. We are not asked to evaluate because that would be impossible. N equals 3 to infinity. That's impossible. We're asked, does it converge or does it diverge? Now let's get into it. So to find what happens at infinity, the end behavior of this, well, we can say, okay, what's the limit of that? As we go closer and closer and closer to that n equals infinity, what's happening to that value? Is it converging to one value, or is it diverging? Is it going to infinity? Is it doing something weird in between? That's what we're asked here. So let's go ahead and do that. So what is the limit as n approaches infinity? And I suck at drawing the squiggly brackets, but it kind of looks like a butt. Anyways, that's kind of weird, isn't it? N squared minus 7n plus 3 over negative 4n squared plus 10n plus 1. Okay, so yay, we can evaluate the limit. Let's go ahead. Oh no. Infinity squared minus 7 infinity plus 3. That's infinity. Oh no, what's happening here? Calc 1 students, this is coming back to kick you in the ass. Infinity plus 1, infinity plus 1 is just infinity. It's infinity over infinity. What do we remember about limits if it's 0 over 0 or infinity over infinity? That's an indeterminate form. Indeterminate. Probably spelt that horribly wrong, but indeterminate. It's indeterminate. You can't. The limit there is just. It's not that it doesn't exist. It either exists or it doesn't exist, but we don't know because it's indeterminate. So how do we do this? Well, hopefully you were taught L'Hopital's rule, but if you weren't, I'll explain it to you. Now you can solve this algebraically, possibly, but let's say you don't. You just want to use an easier form. We're going to use what's called L'Hopital's rule, which says, okay, if a function f of x over g of x equals 0 over 0, or sorry, the limit as n approaches some value a for a function over a function, so the limit as, or I should say x in this case, x, whatever you plug in here, as it approaches some value equals 0 over 0, or it approaches infinity over infinity. Well, you can simply, instead of having this indeterminate form, you can say that this is equal to f prime of x over g prime of x. Okay, so this limit is equal to this, right? So if we have the limit as blah 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 blah, and we just take the derivative of the top and the bottom, well, we could get an actual value from that, and it would make the limit determinate. So let's use this idea of L'Hopital's. We're kind of an easy rule, but let's apply it. So we're going to say 2n minus 7. I'm just taking the derivative of the top. And don't go ahead and do, what's it called, quotient rule here. Do just the derivative of the top, derivative of the bottom. Simple power rule here should work. Sometimes you'll get chain rule, sometimes you'll get product rule. But never quotient rule, really. So 2n minus 7 over negative 8n plus 10. Now, hopefully you see a problem here. I won't even write limit yet. When we plug in infinity, because now that we have this, we need to plug in infinity. Well, we're going to get another indeterminate form, infinity over infinity. Because 2n is infinity, minus 7, oh, well, I don't care. That's pennies from a billionaire's bank account. Negative 8 plus 10. Well, now you're donating to the billionaire. You're giving him a little more to his infinity. But it still doesn't change infinity. Infinity is always infinity. So this is another indeterminate form. Indeterminate. Sad face. So what can we do here if we have another indeterminate form? Well, we evaluated the limit and it was infinity over infinity. So let's do L'Hopital's rule one more time, and we're allowed to do that. Because what's this? This is an indeterminate form, right? It's equivalent to this. It's still indeterminate, so we are allowed to do L'Hopital's rule once again. So let's do that. It's going to be 2 over negative 8. Oh, that kind of looks like a value that's not indeterminate. Well, that's just negative 1/4. That's actually what the limit is approaching. As you plug in values and you go to infinity, the sequence is going to start to get really, 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 really close to negative 1/4. So we can say that the limit as n approaches infinity of this sequence is going to be equal to negative 1/4, which is convergent. Convergent to negative 1/4. Hope you guys enjoyed. If you did, please drop a like, subscribe, comment if you have any questions. I hope you have a wonderful day.